You okay? Okay. Right. It's probably not a very inspiring title to something which I hope you'll find very exciting. Everything that's new is always very exciting, and especially when it's something that my mentor at Edinburgh got me interested in back in 1984. Ewan Clarkson was very much into crustaceans back then. He's obviously very well known for his trilobites, and especially the trilobite eyes. But he was also very into crustaceans as well, and especially the crustaceans from the Granton shrimp bed. So that's really what got me into crustaceans. And then I was lucky enough to find that there was a PhD going in Glasgow on the Bearsden locality, where you find lots of sharks and fish and all sorts of really sexy things. But I worked on the shrimps. So this is not something that directly came out of my thesis, but is something that's kind of related. So they are shrimps. And one of the things about the most recent discoveries in crustaceans is that you can go bing bagging. So you've all heard of Monroe's, Corbett's, Donald's, and Wainwright's, and all the rest of them. This is bing bagging. And this is a bing in shots where sadly I have not found any shrimps, but you do find some really exceptionally well preserved fish and other things. So even going back to the old mine tips, you can find things that are very exciting and brand new to science. And one of the people who has worked on a lot of the things from these locations is Frank Elliott. And some of you may know Frank Elliott from his work at East Kilbride, working with carbon isotopes and a whole bunch of other things as well. So he's known for that, but he is also now known in his retirement for researching fossil fish from the Carboniferous. So he's been looking at these bings. And the interesting thing about this bing is you can see it's got two lumps. There's actually three lumps, but I couldn't fit them all in the one photograph. The two lumps indicate different levels at which the mine was being dug at. So it's quite useful in terms of identifying which levels these fossils have come from by which part of the bing that you found them in. So it's quite a useful thing to know. So bin bagging. The two bings that we're going to talk about are the Westerbraco bing, just outside Airdrie, and the Palaeocaris bing just by Whitburn. And these are two locations where Frank Elliott found one shrimp from each one of these locations. I have been back to these places and I have found nothing. Plenty of bits of fish, plenty of bivalves, boring bivalves. Shouldn't say that. Fantastic fossils, but no shrimps. And to tell you the truth, when Frank gave me his shrimps to look at, I still couldn't see them. Even under a microscope, it took me ages to find these things. And they're absolutely spectacularly well preserved, but it's a dark shale with lots of shiny things on them. And some of the shiny things happen to be shrimps. So it's very difficult to see. So let's have a look at Westerbraco first. There's Westerbraco. That's quite scary. But that's Frank on the, whichever side you're looking at, the right. And Gary Hoare's on the left. He works at the Glasgow Geological Society. That's Frank, and that's him looking at he says his eyesight's not very good, but I think it's absolutely amazing what he's been able to find. So that's one bing, that's a Westerbraco bing. When you go to the Palaeocaris bing, it's a whole different kettle of fish. so to speak. There's not much there. Sadly, Frank found it a number of years ago before he gave me the shrimp that he found there. And the shrimp that he found at Palaeocaris is probably the more interesting of the two. And the chances of us digging that up to find any more shrimps are pretty remote. So what are we looking at? This is a stratigraphy, a chronostratigraphic framework of the Carboniferous. Fairly simple. Everybody knows things like the Westphalian. Most of you have probably heard of the Westphalian. And the Lemurian as well, perhaps. But what we're looking at are sediments from the Langsettian. So that's nice. We know where we're at. And if we look at the records from these various bings, the one just outside Airdrie at Wester Braco is in the Shotts gas coal. That's where they were digging out there. So it's somewhere around there, either slightly above, slightly below, was where the shrimp that came from there was from. And the one from Palaeocaris, it's a bit more difficult to be absolutely certain which level it was that they were digging at, but it's somewhere in the Drumgrey coals, one of them, somewhere in that section. So at least we know round about where it is, and we've got a broad age for it. This, sadly, is the one from Wester Braco. You can see that it's got a tail fan, and it's got a few body segments. I'll use the mouse, I'm sure you can see online. This is the telson. So that's the middle bit of the tail fan, and these are the uropods of the outside here. So these are the outside part of the tail fan of the shrimp. And this is the body. How scrappy is that? Not very much you can tell from that, apart from saying that this is a particular kind of crustacean. So we can tell which group this came from, but we can't exactly say which species it is. This is all we have basically of it. So that image previously is of this section of this kind of shrimp. It's a syncarid shrimp, which nowadays you find in freshwater streams in Tasmania. But in the Carboniferous of Scotland, it's at Wester Braco. And this one we can name Palaeocaris, but we can't say exactly which species of the Palaeocaris because the diagnostic characteristics of this particular animal are on the rest of the body, the bit that's missing. So we've been back to Wester Braco several times trying to find these shrimps and found nothing. I'm hoping that Frank will go back there again and hopefully find some more, but they're very, very difficult to see. Now, let's have a look at the other thing. This is the one from Palaeocaris, and it's actually, I said one shrimp, but it's actually more than one shrimp, believe it or not. The bit circled at the top there is the tail fan. The bit circled at the bottom is an antennal scale and an antenna. And you know what antennae are, they're the feelers. And the antennal scale is just something that sticks out the front of it that looks like a tail. So you don't know which end of the shrimp that you're really looking at. And in between those two things, in between the tail and this antenna, you can see that there's a few legs and they've pointed at with the arrows. So we've pretty much got the complete animal there. There's also a number of other bits and pieces of other shrimps there as well, but I couldn't actually say how they related to themselves, let alone anything else. But this one I could tell was a complete shrimp. Now, we do have a little bit missing of the shrimp as well, because it doesn't really have much of a skin to it. It doesn't have the shell. It's all kind of dissolved away, disappeared, probably because it was a molt. And all we're left with is the molted shedded skin of this shrimp. I tried using AI to produce an image of a shrimp upside down with the tail fan inverted. but I gave up after a while because I came up with some pretty weird looking shrimps and just used a crayfish here and flipped the tail over. But this is basically what you're looking at here, minus the claws, because they didn't have claws like this back in the Carboniferous. So you can see the antennae down at the bottom there. So the shrimp's upside down, basically. You can see a few of the legs, and the tail fan is tucked underneath rather than out as you would expect it to be if it was swimming about in the sea. So it's slightly different. So that's basically what you're looking at. Now, so we've got the antennal scale, which is at the top there. We've got the legs, the thoracopods, and we've got the tail fan. Now, the important diagnostic characteristics of this kind of shrimp are mostly again, in the bits that are missing. But thankfully, there is one particular characteristic that is very diagnostic, and that's the antennal scale itself. Now, let's have a closer look at some of these bits. So the antennal scale is called the scaphocerite in this image here. And you'll see that it's got a series of little jaggy bits along the edge. That's a technical term. So these jaggy bits, the number of these jaggy bits on the edge of this scale can help us define which species this animal belongs to. Now, there are other things which would have helped, like some of the grooves on the tail and the abdomen, some of the keels on the carapace, on the head part of the animal, and the length of the rostrum. All these kinds of things would have been very useful, but lacking that, at least we have this antennal scale with the spiny bits on it. The tail itself, the tail fan, it's very difficult to see as well. And if you do look at the paper, you can see that it's very difficult to see, even with trying to use any enhancement I could to bring this image out. So I had to do a wee drawing beside it just to give you an idea of what it is. But the interesting thing of this one is that the telson, which is this bit here that comes down to almost a point there and back up to the side here, this is very narrow at this point. And all the other animals of that particular genus are a little bit broader. Just a little bit. But there is an obvious other difference, but we'll go into that in a second. And this is the antennal scale. And you can see close up, it's much more obvious what we're looking at. Well, you all seem very convinced by that. It's not easy to see, but the drawing here, you can see little spines coming off perhaps at the edge here. This is the antenna, and you can see segments of the antenna here. It's probably graphitized, actually. I think I could use that term. It's carbonized anyway, but it's a very shiny carbon. So it's very difficult to make things out. But hopefully the diagram at the side there will help a little bit. But you can see there's little spiny bits anyway. So they're quite important. Now, the other important thing is that all the kinds of shrimps that this relates to, the youngest ones are found in the Serpicovian and the Pendlean. So that's where the Bearsden shrimps come in. So they're about here. And then we go down into places like the Whitchurda Water near Churnside. We've got things from Glencourt Home down in the borders as well. We've got something here from the Netherlands. Sorry, Belgium. I have to be careful, it's Belgium. So there's a whole variety of them down in the lower Carboniferous here. But once you get up into here, there's about a 20 million year gap between the shrimps that we're looking at in the Bearsden location, where I did my PhD, and the ones that we're finding in the Bings in central Scotland. Now, just to talk about something slightly different, but not very different, this is research that came out of my PhD, and also the Tweed project. And we all know what the Tweed project was all about. That was all about tetrapods coming onto land, the end of the Devonian, the beginning of the Carboniferous. I worked on the shrimps, so not the tetrapods. But they were just as interesting. Well, I would say that anyway, but they're very interesting. So here we are, Willie's Hole, down in the Borders, very famous for Stan Wood finding a whole bunch of tetrapods there. And I think some of the research is still ongoing on that. So hopefully there'll be a lot more published on the tetrapods from that location. What we're looking at there is this crustacean called, used to be called Tealliocaris robusta. And there was another shrimp from there that was called Tealliocaris loudinensis, but it had a different number of spines on the antennal scale, so I called it something else. Named after Ewan Clarkson's conspirator on the shrimp project back in 1984. This is named after Derek Briggs, so it's called Tealliocaris briggsi. I had to say, the other shrimp from Paul Kennett that Frank found was named after him. It became called Tealliocaris elliotti. Now, having looked at this shrimp, Tealliocaris robusta, for my PhD, I struggled with it because I couldn't see how it could actually be a Tealliocaris. So the excavations at Willie's Hole helped me immensely because there was a whole lot more that came up from that excavation. And there was a number of other excavations elsewhere, one particularly down in near Bristol, where we found some fossil shrimps there. And the fossil shrimps there we named Schrammocaris, after Fred Schramm, the world-renowned crustacean zoologist, whom I'm sure you all have heard of. But that was named after him. So this one, I could see that it had a lot of similarities with Schrammocaris from the English locality. So we called it Schrammocaris robusta. Now that gave us a lot of problems because the shrimp from Bearsden was compared to that and called Tealliocaris robusta as well. But it really was a Tealliocaris. So Teal was he a collector for the Geological Survey, or was he? So he was a member of the Geological Survey. So it's not a complicated Latin name. It's named after teal, but it's also caris for shrimp. So that's why it's called Tealliocaris. So it's actually a Tealliocaris. And there we are. This is Tealliocaris robusta from Bearsden. And it does look very similar. It's a very robust little shrimp. So when you have a very robust little shrimp that comes from Glasgow, what else would you call it? So we called it Tealliocaris weegie. And that's the way it's going to remain. But just to give you something more complicated to look at, the shrimps can be distinguished not just on the characteristics of the shell morphology and the little lumps and bumps and so on. It can also be differentiated on the basis of gross morphology. And this is basically what this is. This is looking at the shapes of the carapace of the head shield of these shrimps. And you can see that they actually plot in different parts of the graph. All the Schrammocaris seem to clump together in the middle there, Tealliocaris off to the right, and some other weird kind of shrimp called Pseudogalathea in another section. So they are distinct. If you don't have enough of them preserved that you can tell what they are, sometimes measuring things and comparing them does help. So this is one of the ways in which they've been differentiated. But Tealliocaris, the ones from Bearsden, do plot differently from Schrammocaris, so they're not Schrammocaris. They are true Tealliocaris, and it's called Tealliocaris weegie. So lessons to be learned. The first one to remember is that it's possible to estimate the level from which the fossils were obtained based on the position on bings. It helps also to know which coal it is that they were digging out of the mines as well. So that's something that's quite useful. The other thing that to think about is that there's always something new to be found in old workings, such as bings. There's always something that's missed, especially something that nobody else can see, like these shrimps. And also, although it's, I mean, many years from when I first started my PhD till now, I hate to think exactly how long that's been. I can't count that high. I'm only a geologist. But as John Lydgate said, the truth will out, and eventually all will be known. I think Shakespeare said something like that as well. So Tealliocaris robusta became Schrammocaris robusta, and Tealliocaris robusta, I can't even say it myself, became Tealliocaris weegie. So thank you very much, and I hope you read the paper.